Okay, so let's continue with our next video in our coding exercise series. So in this video, we will cover append and delete problem, which is on the HackerRank, and it is the easy category question. So let's read the question. You have two strings of lowercase English letters. So you have two strings given. You can perform two types of operation on the first string. So you have basically two string given, S and T, and you can perform some operations, but only on the first string, that is basically on the S. So what are the two operations? Append a lowercase English letter at the end of the string. So it means, so let's suppose your string is S is ABC. So you can append a letter to the S string. So that is the one operation you can perform. Delete the last character of the string. So you can delete the character from the string. Performing this operation on an empty string result in an empty string. So if the string is empty and you perform the delete operation on the empty string, so the output will be empty as well. So given an integer k and the two string s and t. So we in the first line it's already mentioned you have two string s and t. Now in the third line, fourth line, you can say it is also mentioned given an integer k. So we have some extra integer k is given. Determine whether or not you can convert s to t by performing exactly k of the above operation on s. So we have some number given integer 6. So we have to tell, can we convert s to t in exactly 6 operation? If yes, then we can print yes, otherwise we can print no. Right. So let's go through the example. So this is the example. S is equal to ABC, T is equal to DEF. So to convert S into T, you could see none of the letter match, right? So A, does A match with D? No. All right. So what you need, if you have to convert S to T, what you need to do is you have to basically delete everything from the S and reconstruct again. All right. And if you delete, you can delete only one character at a time. So you delete A, so that is one operation. You delete B, that is second operation. You delete C, that is third operation. So three operation you perform, and then you what you can do is you can append the D, then you can append E, then you can append F. All right, because that is also the English letter because we need D, E, F. So out from A to Z, we can pick D, E, F, and we can append into the S. So append is also three operation and delete is also three operation. So 3 plus 3, 6. So you can say yes, within exactly 6 operation, I am able to convert S into T. Right. So the answer will be yes. So it is going to return yes. Let's see another operation, another example. Hacker happy, hacker rank. So S is hacker happy, T is hacker rank, and we have to check, can we perform, can we convert S into T in exactly 9 operation or not? If yes, then if we are able to convert then in 9 operation, then we can return yes, otherwise we can return no. So we will start. Okay, H is equal to H. Okay, A is equal to A, C is equal to C, K is equal to K, A is equal to E, R is equal to R. All right. So till R, both the string matches. So it means, and then H is equal to R. No. So it means from H we need to delete everything. So how many letter we need to delete? H A double P Y. So five operations. So basically five operations we need to perform, and then to make it so it will become hacker. And how many character we can append to make it hacker rank? So we can append R, we can append A, we can append N, we can append K. So basically five delete operation and four append operation we can perform. So 5 plus 4 9. So we can perform exactly 9 operations. So answer yes. Now you can say S is equal to ABA and T is equal to ABA. And can we perform operation in 7? You could see S and T both are equal, right? So ideally you don't need to perform this operation, right? So but we have given 7. So but can we perform? So let's try to delete everything. So let's suppose if you delete ABA, right, and then back again insert ABA, right? So if you delete A, then delete B, then delete A. Basically, you are so basically, like there are two things you can do. So either reconstruct reconstruct the entire string. All right. So either you can do this one, or either modify the string to convert to T. And in modify means delete, append, or both, or operation. So this is the only two way, like you can convert S into T. All right. So this is the only two way. So if you see A B A, so A B A, right? So this is the second example. Let me take a cursor. So this is the second example, A B A. You can say, okay, S and T both are equal, right? So if both are equal, do we need to return no? But now answer is no. The answer will be yes, but the how it will be yes, because we have not even performed even a single operation, and the string is already equal. But can we perform some operation and still it will become equal? Yes, answer is yes. So let's suppose if we delete A, if we delete B, if we delete again A, so we perform three operation. And now if we insert A, if we insert B, if we insert A, so 3 plus 3 is 6 operation, and we reconstruct S. But we only perform six operations, so we reconstruct the string, but still we use six operation. We have not used the seven operation. So answer should be like no, but no. So if you read the question properly, it is mentioned performing this operation on an empty string result in an empty string. So what you can do is you will delete A first, you will delete B first, you will delete A first, right? Then S will be empty. On the empty string, you will again perform delete. So on the empty string, you are again going to perform the delete operation. So total four delete you perform. And then you are going to set A, you are going to set B, you are going to set A. So total 4 plus 3, 7. So answer will be yes. So let's see. The next example, Ash, Lay, and ASH. So A is equal to A, S is equal to S, H is equal to H. Now we need to convert Ashley into Ash. So to convert Ashley into Ash, we need to delete these three. And to delete these three, you have to delete L, you have to delete E, you have to delete Y. So basically three operations you need to perform minimum. But they said, can you do in two operations? So answer will be no. No, we can't do in the two operation. All right. So basically, if you see from this example, what we can conclude, just this example, right? From this example, we can conclude is if the number of operation we required is greater than the k, right? If a number of total operation, if number of total operation required is greater than k, the answer will always be no. All right. So if number of operation, because number of operation required is 3, and which is greater than k, then the answer will always be no. So this is one. Also, from this example, one thing come into like picture. If a number of operation, like number of operation, like 3 delete, 3 insert, if a number of operation equal to this k, if a number of required operation equal to k, then we have to return yes. All right. So two is done, right? Now, so these are the like straightforward example. This example, this first example, and this third example. This is a straightforward example. All right. Now let's see what else we can do. So here ABA. You could see it's already equal, right? But we have given seven k is equal to 7. So how many operations required? Zero, right? Zero operation required. Ideally, zero operation required, right? So, but we have 7. So we have more number of required operation. So it means we can use uh, these things to perform, to try to reconstruct the entire string. So if we delete A, if we delete B, if we delete A, and if we insert A, if we insert B, if we insert A, so total six, right? But still we have one left. If we still have one left, then you can perform the delete on the empty string. So which means if we have this condition, if the number of operation required, the number of operation required, if k is more, if k is more, like number of operation required is 0 in this case, and but we need to perform in 7, so will the answer will be yes. So if you just look this uh, example, then you can say yes, the answer will always be yes. But no, there is a little catch in this question. So if you try to run the code now, then you will get some error. Let's try to write some code. Right. So what is the first step? So first step is we need to find how many insert and how many delete operation required. And to find that how many delete operation, how many insert required, we need to calculate the basically the common length. So as an example, in this question, we will try to calculate the common length, how many common length, and whatever the remaining character uh, in S, that is basically the delete operation. Whatever the remaining character in T, that will basically the insert operation. All right. So let's try to find the common characters. Okay. Find the common length. Common length is equal to 0 for uh, S element, T element in zip of S comma T. All right. Or either you can use the zip function, or either you can run a loop on the minimum of whatever the length is. Anyhow, like both are same. So if SC is equal to T, then common length plus is equal to 1. Else break. Right. So like in this case, so A is equal to A, yes. So common length is 1. S is equal to S, yes. So common length is equal to 2. H is equal to H, yes. So common length is equal to 3. Anyhow, because of the zip operation, it is going to perform the minimum of either S or T. In this A, B, A, so the common length is 3, right? In this operation, the common length is 0. In this example, the common length is 2. So we found the common length. Now, how many delete operation required? Deletions. Deletions required. Or delete required, you can say. Delete required. How many delete required? So let's suppose in this example, what is the common length? Delete can be only be performed from S, right? So whatever the common length, you should not delete that common length because that is already common. Like why you should perform the operation on the common length, right? Whatever the remaining character, that will be the delete. So length of S minus common length. So length of S is 1, 2, 3, 4, 5, 6. 6 minus 3, 3. So in this operation, how many delete required? 0 delete required. I like if we just forget about the k is equal to 7 or not. Uh, if we find the common string, and after that we know okay everything is common, we don't need any delete. So how many delete required? 0, 0, length of 3, 3 minus 3, 0. And in this, how many delete required? So because nothing is common, so common is 0, and length of s is equal to 3. So 3 minus 0, 3. So 3 delete required because we have to reconstruct everything, right? In this, how many delete required? So length is common length is 2. Total length of s is 3. So 3 minus 2, 1. 1 delete required, right? So we found the delete required. Insert required. So how many insert required? So length of t minus common length. right? That is the insert required. So example, uh, let's take this example. Uh, this is, one second. Let's take this example. So we figure it out. Okay, how many we need to perform the delete, but how many we need to perform the insert. So whatever the common length. So we found, let's suppose, whatever the common length, whatever the remaining character which is not common from the T, we need to insert. So do we have any common, do we have any element in the T? No. So the insertion required is 0. In this case, do we, after common character, do we have anything to insert? No. So insertion required 0. In this case, common length is 0. So how many insert operation required? 3, because the length of T is 3. In this case, how many insert required? With the common length is 2. So how many insert required? D, because we have one element which we need to insert D. So a total number of total operations required is equal to delete required plus insert required. So we figure it out, right? How many delete required, how many insert required. Now what you can do is, because we already figure it out, if total operation required is equal to K, we will return yes, because we have to tell, we have to return yes if you can perform exactly in K. And we know total operation required 6, and if it is equal to 6, if it is equal to K, then we can return yes. Okay. Elif, elif, we can take this is we can take let's take this example. All right. So if total operation required, so 3 operation required, is greater than K, that will be basically else. Let's one second. Let me do else directly. That will be easy. Uh, or let's put else. So if total operation required greater than K, we return no, else. So if total operation required equal to K, that is the first example, we will return yes. If the total operation required, like here, total operation required is 3, which is more than 2, so that is the minimum operation 3 required, right? So this is going to return no. So we already figure it out. Uh, two two things. Let me rub this. So two cases we already figure it out, right? What is happened? Uh, why this screen is not going? Okay. So we figure it out, two operations. So this operation done, this operation done. Okay. Now let's see another example. So because in this case as well, we are returning yes. So which means if total operation required less than. So this case is basically total operations required is less than K. All right. Basically, we have more moves given. Do we need to return yes? Do we need to return yes? If we do this, some test cases will pass, but some test cases will fail. Like example, sample test case is passed, right? And if you try to submit the code, you could see most of the test cases run, but 2 test cases fail. All right, because here there is a little catch. And what was the catch? I have told you, perform the operation of the delete string. So let me show you. Here is a little catch. So here, if total number of operation required is less than K, that is the else condition. Within the else, what we need to do is we will check. So this case we figure it out. Okay, total operation required 0. 0 is greater than S. It means yes. But let's see this example. right? And it is going to fail in like in this example. That's why like there is a catch. So total operation required. How many total operation required? This is a common. So one delete required, and one append required. So total operation required two. Is two is greater than f. So number of moves required is more. Similarly here, number of move required are more. And here in this case, we are saying okay, if number of moves required is more, we are returning yes. So similarly, if we apply this logic, then it means in this case as well, we have to return yes. But that is wrong. Why it is wrong? Because we have in the question it is mentioned, can you perform in exactly key operation? Right. So here you can perform two operation, right? But the five is given. So if more moves given, right, you have only one thing left. Try to reconstruct the entire string because you can't modify, right? You can't modify. If you try to delete C, what you are going to delete after that, right? So only an operation left is you have to try to reconstruct the entire string. So if you try to reconstruct the entire string, you delete A, sorry, you delete A, you delete B, you delete C, right? And three operation done. Then you insert A, you insert B, right? Or maybe, all right. So you insert B, you insert D. So six operation required, right? So but we have to perform in five. Or maybe you can say, okay, I will do A, B, I will delete C, right? So I will delete C, I will insert D, right? Two operation. Then I will again delete D, right? Three operation, I will again insert D, four operation. Then after that, still one operation left. If you delete D again, then the string will become AB. Anyhow, you have to perform the six operation, right? So it means if the number of operation required, the left number of operation required, like if 2 minus 5 is equal to 3, if the even number of operation is required, then you can like you can return true. But if you just do that, which means like in this case it is failing because 7 is odd, but in this case it is yes, right? So in this case why it is yes is if the total length of s plus t is less than the number of moves. So if the total length is less, so 6 is less than 7. So it means you can reconstruct entire thing. Here you are not reconstructing, you are modifying, right? So because if you try to reconstruct, you can't reconstruct. Like if you try to delete A, try to delete B, you try to delete C, so three delete, and if you try to insert A back, you try to insert B, finish, five operation finish. You can't construct. So here what you can do is you delete C, you insert D, two operation. Again you delete D, you insert D, four operation. Again you delete D, all right? That is the five operation. Uh, but if you delete D, it will become AB. So you have to perform six operation, all right? So basically the left number of operations should be always even. Left number of operations should be always even. And in this case, total length like of s plus t should be less than number of 7 because you can reconstruct it. If you delete A, you delete B, you delete A, then you can say I can insert A, I can insert B, I can insert A, but still one operation left. But in the question it is mentioned you can perform the delete on the empty string. So what you can do, you delete A, you delete B, you delete A, three delete, string is empty, you can perform one more delete. So that is on the empty string. So four delete perform. Now three insert you can perform. So total four plus three is equal to 7. So that's why like it is a little catch here. And so one second. So that's why if you just go with this code, most of the test cases is working, but two test cases will fail. So what you have to do is you have to check if length of s plus length of t is less than k, right? You have to return yes, right? Else return no, or or. So this is one condition. If length of s plus length of t is less than k, because length of s plus less than t is less than k, which means you can reconstruct entire string, right? In that case, you can return yes, or if the number of operation left. So if k minus common length, if the total number of operation required, oh sorry, k minus common length divided by 2 equal to 0, then you can return yes. So let's try to submit it. Did I did something wrong? Why it is syntax error? Okay, still two test cases fail. Uh, or is it or k minus common length divided by 2? Let's see like why it is failing. Okay, so I did very small mistake. Even though while explaining, I am telling the number of remaining operations. All right, because two operation we already have to perform. All right, two operation we know we have to perform, and the remaining operation is three. All right, so with three, you can't uh, convert s into t, because three means either if you perform one delete, then you have to perform one insert. So if you perform again delete, then you need one more insert. So basically, even number of operation required. So that's why instead of minus component, I have to perform k minus total operation of required. If k minus total operation, with that total operation required 2, and the remaining, let's suppose k is equal to 5. So 5 minus 2 is equal to 3. If that remaining is divisible by 2, which is basically the even number of remaining, then I can return yeah, true. Otherwise, yes. So if try to submit the code, now all the test cases should work. Yes, all the test cases like working. So this is the question, and it's like easy category question, but here just a very little catch, because otherwise if you see, we know, okay, if the total number of operations is exactly k, okay, yes. If the total number of operation is like greater than k, which means you can't convert s into t, then return no. And in the third case, if you just look one example, then maybe you can say yes. But if we see like couple of more example, which is already given, so I have not taken any other example, I just take from there only. ABA, Ashley, HackerRank. So this kind of example only. From this example, you got to know, okay, we have to perform these operations. So that's it. That's the end of the video, and thank you.